Okay, question 6. Okay, what I noticed with this one, I think the photocopying here wasn't perfect, but the grid that I had here wasn't particularly helpful, so I actually went over the grid here. If you notice, every 10 squares I've drawn a horizontal line, 10 squares again another horizontal line, and I've done the same then going across 1, 2, 3, 4, 5, 6. I've drawn lines going up. Okay, in the exam the graph paper will be perfect, okay, but obviously when we photocopy sometimes it's not so good. Okay, but by doing those lines there, I think it'll help us answer this question. Okay, so maybe you can have a think about doing that if you haven't done this question yet. Number 6 then, so let's have a look. A 1200 litre tank initially contains 200 litres of water. A valve is then opened which allows 150 litres of water to flow into the tank every hour. On the graph paper below, draw a line that will show the amount of water in the tank at any time up to 6 hours after the valve was opened. Okay, so I think what's clear about here, we've got quite a large tank, is 1200 litres, and it says it initially contains 200 litres of water. Okay, so that's what you have at the start, so it's quite empty really, there's not much water in there, but then a valve is opened and then it floods. Okay, so 150 litres flows into this tank every hour. Okay, so it starts to fill up. Okay, over a number of hours it starts to fill up. So, so we need to represent this on our graph. Okay, so when it comes to a scale, hopefully you can see, look, we're starting at 200, okay, because that's initially means at the start, of course, yeah, so at the start we have 200 litres of water in the tank, so I could even put 200 here at the bottom. Okay, right, and I can do that, there's nothing wrong with that, because that's what we're starting with, and then every hour it fills 150. Okay, in terms of a scale, I don't think it's going to hurt you if we did go up in 150s. Okay, so we'd have 200 there, another 150, we're going to be 350, 500, 650, 800. So all I'm doing is adding 150, 950, 1100, and of course 12,000. Sorry, 1200. 550. Okay, of course the tank won't actually get to that level, won't it, if you think about it, because you can only get 1200 litres, it says in the question, so we won't actually use all of this scale here, but the good thing is that the scale I've used, everything will fit in. Okay, so it's a case now of putting points in this graph paper. Okay, so we have our line. Of course, we can have a point there, haven't we? Because at time 0, right? Don't forget, it said initially it contains 200 litres of water. So when time is 0, there's 200 there. And then it says the valve is opened and 150 litres of water flows into the tank every hour. Okay, so 150, right? We're going to have, after 1 hour, if you think about it, we'll have 150 added to the 200, so we're going to be here, aren't we? Okay, after 2 hours we'll have another 150, so that will take us to 500, 3 hours, and so on. You can see what's going to go on, and we'll have a line there, you know, we can keep going. 4 hours 800, 5 hours 950, and 6 hours 1100. Okay, as I said, we're not going to use all of that graph paper there. So draw a line, and we have then a type of conversion graph, okay, a conversion line. This may help us with part B. Now part B, it says how much water was in the tank after 2 hours and 48 minutes. We can use this line now to help us, like I said, there's a conversion graph to work out how much water was in the tank. So it says 2 hours and 48 minutes. So it's going to be between 2 and 3 here. Okay. Now what I would do is, I would think about here how many gaps there are between 2 and 3. Now clearly there are 10, yeah? There are 10 squares between 2 and 3. So the hour that exists between 2 and 3, that hour is divided into 10. So if you think about it, 1 whole hour, if you divide 1 whole hour into 10, okay, you'll get 6 minutes, won't you? Because if you think about it, in an hour, you've got 60 minutes, okay? If you divide that by 10, you get 6 minutes. So each square represents 6 minutes, if that makes sense. That'll be 2 hours, 6 minutes, 12 minutes, 18 minutes, 24 minutes, and of course 30 minutes is in the middle, isn't it, if you think about it? Okay, 36, 42, and 48. 48 will be there, okay? And it makes even more sense then when you see there's 2 squares left. If you think about it, 2 squares would represent 12 minutes, which, yeah, if we add 12 minutes on, you get to the next hour, don't you? So that's perfect there. That's your 2 hours there and 48 minutes. So all I need to do is draw a line up to my conversion, okay? And I can read across then from here, okay? So I draw a line would be best before you do any reading. Okay, and it hits the axes there, so it's just short of 650. And of course we do need an exact value there as well, so we have to be really careful, okay, on this. We have to be really careful, but again we can use the same principle, the same reasoning. We've got here a gap of 10 squares. From 500 to 650 is 10 squares, but those 10 squares actually represent, don't they? They represent 150, yeah? They represent 150. So if we have 150, okay, in this case 150 litres, and you want to divide that by 10 squares, you will actually get out 15, okay? So each little square represents 15, okay? Because I've divided, as I said, the 150 litres by the 10 squares, so each little square represents 15. If we count back in this case, you've got 2 squares here, so that would be 30 litres. 30 litres short of 650. So 650 take away 30 is 620. Okay, so there's my answer. 620 litres at that specific time.